Alright, so I'm upside down. My name's Austin Bren, doing combined spectrum problem for organic 1. Alright, so today our chemical formula is C4H6O2, and first we will calculate degrees of unsaturation. We know the formula for this is 2C plus 2 minus our hydrogen number divided by 2. Alright, C equals 4, H equals 6. So this will look like 2 times 4 plus 2 minus 6 divided by 2. Now, 2 times 4, 8, plus 2, 10, minus 6, 4, divided by 2 equals 2. So this means that we have the presence of a pi bond, or a ring, or both. And we will determine that. So starting with our first spectra, point out a couple of key points. So we see at the about, let's call this 1150 mark, a CO stretch. So a carbon bound to an oxygen. I'll just write this off the side as well. CO stretch. And that would account for one of our 2 oxygens. And the other oxygen is right here, a little bit downfield of the typical 1700. We'll call this 700 plus, what would that be? I should say 1750. So it's being pulled a little more downfield, indicating an electronegative group beside that carbon. This is a carbonyl stretch. A little further downfield, maybe it's bound to an oxygen. We will find out. I'll write this. Alright. Another thing to point out, downfield we have the characteristic sp3, sp2, CH3, alkane stretches. I'm going to write that. And then fourth thing that's not apparent on here but easily recognizable is this missing broad OH peak. I'll write that as well. No 3300 broad OH peak. Alright, so we know we have a carbonyl, we know that we have carbon bound to an oxygen, so likely ester. The carbonyl covers 1 degree of unsaturation, so the other must be a double bond, but we don't see any carbon-carbon double bonds or triple bonds. So this might indicate a ring, but let's find out. Let's go a little deeper and check out the C NMR. So with what we know, go ahead and write this down here. We have a carbonyl, likely bound to an oxygen, forming an ester functional group from above. And then for all we know, to cover the other 3 carbons not present, carbon, 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 we'll assume with this that we have hydrogens present, but we only have 6 hydrogens, so we don't really know what's going on here, further indicating that it might be a ring, but let's also find out. So we know that this is split typically we see sp3 upfield, sp2 downfield. Well, lucky for us, we do have sp2, this carbonyl carbon, which is very likely what this peak is showing, carbonyl carbon. Now, downfield in the upfield half, typically you see a carbon that is having electrons pulled by an electronegative group, and this would make sense with a carbon bound to an oxygen. So this is our adjacent ester carbon. We'll write it like this. Now as far as the other two, our rough diagram shows the next peak at about 29 would just be a little bit further away, so maybe once removed from the ester oxygen. And we see a very close peak beside it at about 21, which would mean even more removed from the ester oxygen. So far, everything's lining up, but we don't know what's going on here. Alright, so now we look at our final spectra, the HNMR, and we have 3 readings. So, also to note, we only go up to 5, so this is only half of the full spectrum. But these are, if this is the only data that was collected, that means that everything, all these hydrogens are off of sp3 carbons, which makes us believe that our carbonyl sp2 carbon we know is bound to an oxygen to form the ester, but it is not bound to a hydrogen here, meaning it must also be bound to a carbon. This is why we only get this amount of readings. Now, looking at the spectrum, we have 3 peaks, all with 2H integration, and then we have a triplet. Here we also have a triplet. And here, 1, 2, 3, 4, 5, we have a quintuplet. All right. I'll redraw this down here. So, very likely, same as with the CNMR, in the upfield portion, we have 2 sides of the upfield portion. Typically on the right, you have carbons bound to less electronegative atoms, whereas further downstream in the top half, you have carbons bound to more electronegative atoms. Well, this will be the same as we see on HNMR, where downstream in the first half, you have a carbon bound to an electronegative atom. So this is our CO, and those hydrogens that are being picked up right here are associated. Looking a little bit further, same as the CNMR, we will see that this triplet, since it's a little further downstream than this, means it's closer to the electronegative group, meaning that's associated. And that leaves our furthest carbon from the electronegative group being the most upstream, indicating a ring is our most likely final product, and this makes sense. Each carbon has 2 hydrogens. Our triplet, we can see adjacent, you have 1, 2 plus 1 is 3, that's our triplet. Adjacent to the carbonyl, you have 1, 2 plus 1, 2 adjacent plus 1, 3. Accounts for this triplet. And then our furthest, most upfield peak, furthest away from any electronegative group, has 1, 2, 3, 4 adjacent hydrogens plus 1, 5, indicating our quintuplet. So, redrawing this structure, everything adds up, and we are locked in with gamma butyrolactone. As our final structure. And then all of that data is compiled into this diagram showing everything that we had just talked about. So feel free to pause here and check, make sure everything matches up for yourself. Thanks so much.